My name is Gerald Neal. I'm a Chialisp enthusiast from southern New Jersey. Blink Mojo is a money privacy application designed to work with the Chia blockchain.
So why do I care about money privacy? To me, money privacy is important for a secure, functioning economy in the long run. There's no other way. Also, decentralized blockchains, for all their attributes, typically have serious privacy issues. For example, Bitcoin. The case against Bitcoin privacy can be expressed in the following example. Your employer should not know where you buy bread, and your baker should not know your biweekly salary. The first edition of Blink Mojo was released in October 2021. It was inspired by a blog post by Brent Crowan from earlier that year. The repository for that edition is on GitHub, and in that form it was insecure and essentially unusable to others, but I did use it once and record the output, and in retrospect it does look like it did its purpose and the transactions were essentially private as far as the blockchain is concerned. The second edition is called Blink Mojo Secure. It's written in Python for usability and uses BLS signatures for security. The latest version of that was released last week, and I will demonstrate that for you today. Blink Mojo Secure is designed in Python and Chialisp to work on Chia testnet. It's 100% open source and available for free download on GitHub. The purpose of this demonstration is to hopefully inspire more downloads of the application, usage of it, and feedback for improvements. So let's get started. The first step in running Blink Mojo is to download the GitHub repository software to your local system. And we can do that now. The first command is git clone and then the repository address. I'm using Visual Studio Code. At the bottom, there's a window that has my command line prompt, which has the command git clone my repository address, which I'll run right now. That downloads the software to my local directory, which we can see with an ls command. And then we will change directory into that new directory. And in there, we have the README, which has the rest of the install instructions. So we'll open the preview, and we did the first two steps, and now we'll copy and paste to do the third step. So basically we're creating a Python environment inside the Blink Mojo directory, and what that will allow us to do is install other modules and segregate them to just this virtual environment and not apply them to the general system, and also segregate the modules from other Python virtual environments. So we just have to activate that environment. We copy that command from the preview, from the README, and we will just activate our virtual environment. That is successful as indicated by the prefix to our prompt now, which states VN for virtual environment. The next step is to install the requirements of Blink Mojo Secure, and essentially that is just Chia DevTools. So copy, paste, and that takes a little while to install, and we can just verify what I just said by going to the requirements.txt file. You can see there's only one entry in there, and it's Chia DevTools. In this case, it's version 1.2.1, which is the latest version as of weeks or months ago. I'm not really sure, but that's that. In the meantime, it's probably worth looking at the Blink Mojo demonstration slide, which describes what the program will actually do. And essentially we have 4 wallets. On the left there's actually 3 of those wallets. Each one of the pyramids represents a coin. And the green coin represents the faucet wallet. The red coin represents the niche privacy wallet. And then the blue and the gold coins represent what's in the decoy wallet. Those will all be combined into a spend bundle, which will eventually end up in the 4th, much of it will end up in the 4th wallet, which I didn't color code, but I probably should have, which is essentially your anonymous wallet. That's your target wallet. There's a parallel destination, which is basically back to your decoy wallet. It's probably worth noting that in Chialisp, that each coin is represented by 3 elements, one of them being the parent ID, another one being the amount, and then the 3rd element is the puzzle hash. All of those 3 elements combine to form the coin ID. And this slide pretty much demonstrates in visual form how the faucet element of Blink Mojo works, where you have a unique coin ID created by the value that's transferred from a faucet to your faucet wallet. And that coin ID using Blink Mojo becomes the parent ID of your anonymous wallet's value in the end. So essentially we're taking the lineage from a faucet and applying it to the value that's in your anonymous wallet at the end. And the niche privacy coin has a lineage of its own, which essentially disappears in this transfer. The bottom half of this spend bundle are the 2 decoy coins, and their purpose is to just create a parallel transaction where the value gets mixed in to the end result and you're not really sure if the value came from one source or another. As per the instructions, it's important to put a small amount of Mojos from a faucet into your faucet wallet. We can get a wallet address for the faucet by entering the command Chia keys show, which will show all of our wallets used in this demonstration and their first wallet address. For the faucet, our wallet address is here. We'll just copy it and we will go to the testnet faucet available at XCH Dev Discord channel. This Discord channel and the faucet itself have been put up by Steve Stepp. So shout out to Steve. Great job here, along with many of the other contributions to the Chia Blockchain project and other open source projects. So we just enter the command /faucet and then the faucet address, which is, the faucet wallet address, which is TXH, TXCH, etc. at the bottom there. And we just hit enter and it says wait 5 or 10 minutes, which we'll do. You can see with the command Chia wallet show that our faucet wallet, these are our 4 wallets, anonymous, faucet, decoy, and niche privacy. We can see that our faucet wallet is unfunded at this point. We're still waiting for the faucet to transfer over funds. I'd like to take a moment to demonstrate that our anonymous wallet is unfunded. This is the state before we start. So by now our wallets are funded and we're ready to run the application, which we'll do now. We're going to just reset the command line and we're going to follow the run instruction from the readme python blinkmojo.py. We'll just run that program. And it's asking us if our faucet coin wallet is synced and funded for greater than 1,000 mojos. And a little notation that says typically this is a low value burner wallet funded by a faucet or a pool having no coins with parent ID lineage back to you. Is the faucet coin wallet synced and funded? So we'll open up another command line. So we have two over here, two shells. And we'll do Chia wallet show. And we'll make sure it's going to show the contents of our faucet wallet, which is number 2. And it is funded. Again, thank you for the testnet faucet run by Steve Stepp. So we'll go back to our Blink Mojo application here and just answer yes. It's the faucet coin wallet is synced and funded for greater than 10,000 mojos. It has 1 trillion mojos. The next question, how much XCH do you want to move from your Needs Privacy wallet to your anonymous wallet? We're going to go back to the slides. Again, Needs Privacy coin will be 4 trillion mojos. Basically, it's going to be a 4 TXCH, for 4 XCH or 4 TXCH transaction. So we put 4 in there. It gives us feedback that 4 XCH is 4 trillion mojos. Just to reiterate the unit of measure. And what is the XCH address of your anonymous wallet? This will be the destination wallet. Again, we showed earlier that this wallet has 0 value in it right now. But right now, all we need is the TXCH address. So we'll do Chia keys show in our other shell, and address is right there. So we copy it. We'll go back to our Blink Mojo shell, and we will paste the address there, enter, and what it's doing now is it's sending a coin from our faucet wallet, which is synced and funded, to the blockchain, and we will just await confirmation. The next item that Blink Mojo is prompting us to attend to is the question, Needs Privacy wallet synced and ready? And just do a Chia wallet show, make sure we're synced to our Needs Privacy wallet, which is number 4, and make sure that we have enough funds, which we do. We have greater than 10 TXCH, and most importantly, we're synced and ready to go. So at the Blink Mojo prompt, we shall enter yes, and this is now sending another smart coin to the blockchain for further use later, and we just wait for confirmation at this point. The next step is to check to see if the decoy wallet is synced and ready. Is it funded with greater than 4 XCH? We'll jump over to our other shell. At the prompt, we'll run Chia wallet show. We'll make sure that we pick our decoy wallet, which is number 3. And in fact, that is funded for more than the necessary amount. It's funded with 9 TXCH and some change. Again, we're in need of 4 TXCH for this transaction. We'll jump back over to Blink Mojo and we will answer Y for yes. Decoy wallet is synced and ready. It's now asking us for the address of our decoy wallet. So we'll jump back over to the other shell. We'll do Chia keys show, and we'll grab the TXCH address of our decoy wallet, like so. We'll enter it into Blink Mojo, and now it's sending a smart coin to the blockchain. And while we await confirmation of this transaction, we'll just point out that this particular step is 2 parts. Decoy coin is first sent to the blockchain, and then the decoy value coin is sent afterwards. We have all the information entered that we need for those 2 coins, so they will happen one after the next without further prompting. So at this point, Blink Mojo has finished running. If we look at the README, evidence of successful completion would be status success, and we see that at the end of our message. I'll open this up a little bit so you can see where we left off until where we are now. We run Blink Mojo. It creates a faucet coin. It creates the Needs Privacy coin, and then it creates 2 decoy coins. Then it creates a spend bundle with a secure signature that spends all 4 of those coins successfully. Where does the value go? Again, back to our diagram, the value goes to 2 outputs, one of them being the anonymous wallet and the other one being back to the decoy wallet. Again, the main point here is that the lineage of the faucet coin will end up in the anonymous wallet, and there will be no evidence back to you. We can go to our other shell and just make sure that the value is in our anonymous wallet now. So Chia wallet show, our anonymous wallet is number 1. And you'll remember earlier in the video that there was 0 TXCH in there, and then now there's 4 TXCH in there because it was blink mojoed in. It's the best way to put it. We could do an audit on the one coin that went over to the anonymous wallet to verify that the lineage points back to the wallet, to the faucet wallet, and then back to the faucet itself. But you can just take my word for it that it works, or you can take a look at the GitHub repository. I've saved a few example transactions, and you can verify them yourself. I encourage you to actually download this software and run it yourself on testnet. If you run it on mainnet, it's at your own risk. You will probably lose value. The main point of Blink Mojo is that Chialisp offers a money privacy opportunity in a couple ways. One of them is that it's a Lisp, so at this moment of block formation, value transfers, but nobody can tell exactly where it originated or where it went to for sure. Not even you as the user can figure it out. And honestly, it doesn't matter as long as all the inputs match the outputs. Another feature is that instead of using a faucet, if one is unavailable, you could set up a small temporary farm, and connect to a pool temporarily, and then have the pool rewards go to one of these faucet cold wallets that you set up, and just use Blink Mojo from there. And when you're done, just disconnect from the pool. There are other opportunities in the future, probably to use the offering system, the Chia offer system, where you could probably offer a certain amount of XCH for more than you're asking for in return, so that it's essentially an offer that can't be refused, and the public, whoever is the taker of the offer, would end up sending value to your faucet wallet. And when you do Blink Mojo, it would inherit their parent ID lineage. There's all kinds of privacy opportunities in Chialisp and on the Chia blockchain. So I'm not sure I summarized that great, but it's all in the description on the GitHub repository. One potential criticism that this technique tends to attract is that the whole faucet process, might draw attention to your IP address. The same thing if we were to utilize a pool. Maybe the pool knows the IP address that established the connection. Another criticism might be that somebody could, look at the mempool logs and see that the one spend bundle had all 4 of the coins spent at one time. Of course, mempool is ephemeral. It comes and it goes most times, and I've heard criticism that you could maybe have 2 full node operators, confirm that they both have the same spend bundles and say that these spends were all from the same person, same controller. The main point of all these criticisms, whether it's the IP address or the mempool audit, is that none of that is on chain, and therefore it's essentially out of scope for what we're trying to do with Blink Mojo. All we're trying to do is create some sort of break in the lineage of the coins and some sort of doubt as to the source and the destination of the value on chain. If you feel like things other than the chain matter, then you basically don't buy into the concept of decentralized consensus. And there's nothing I can do about that. In conclusion, there's a lot more to Blink Mojo and Chialisp money privacy opportunities. I invite you to try the software and provide feedback to me so I can improve it, or others can improve it, because it is open source and you're welcome to fork it and play around with the code and the concepts. I look forward to further discussion online and subsequent videos. Thanks.